I'd like to now look at a few other examples of solving trig equations where you have to use a calculator. First of all, let's look at solving sine of theta equals negative 0.6 on the interval from 0 to 2 pi. Okay, this is indicating that we need to make sure that our calculator is in radians. I know that I'm going to have to use the calculator for this particular problem because of the negative 0.6. The decimal means that I'm not going to have a nice triangle. You don't necessarily have to have a decimal to know that you're not going to have a nice triangle, but that's a sure indication that you will have to use your calculator. All right, first of all, this particular equation is already solved for your trig function. And so what I need to do first is I need to determine which quadrants that this is going to be located in. All right, so I'm going to take this just down below and rewrite what I have. I have sine of theta is equal to negative 0.6. I can put that this is over 1. Sine, I know that is the ratio of y over r. Okay, r is obviously going to be positive. Y in this case we see is negative. Okay, so we're going to say y is negative in quadrants 3 and quadrants 4. So we've nailed down where these particular solutions are going to lie. Okay, we'll go ahead and draw a picture. So we know that we will have a triangle in quadrant 3 and a triangle in quadrant 4. We'll call this angle around theta 1, and then we'll call the other angle all the way around theta 2. Okay, from here we need to use our calculator. Okay. Basically on these, what you can always do is to find your theta value, just use the inverse of the function that you've been given. So the function I've been given is sine. I'm going to be using sine inverse of the value, negative 0.6, to find the angle. And so theta is going to equal sine inverse of negative 0.6. Okay, be sure you're in radian mode. When you type this in your calculator, you will get negative 0.64350110088. Now, this is definitely not in quadrants 3 or quadrants 4. This is a negative angle. It actually, I guess it is in quadrant 4, but it's not the proper kind of answer. In other words, these answers we see that we're wanting to start from the positive x-axis and we're wanting to rotate around, so the answers for theta 1 and theta 2 should be positive answers, not the negative value here. Okay. On here, what in the world would we do with the negative 0.64350110088 then? What we do with this number is we treat it like a reference angle. In other words, we can see that that particular value is actually the reference angle for the answer that's in quadrant 4. Okay, so here's what we're going to do. You basically just need to use your head to do these kind of problems. Theta 1 we see is in quadrant 3. If this particular value is acting like a reference angle, first thing we need to do is we need to make sure, if we're going to use it as a reference angle, to take its positive value. So instead of having negative, we're going to say if we're using it as a reference angle, just take the negative off, and we're going to be using this value as a reference angle. Theta 1 is pi, in other words 180 degrees, plus that reference angle. Okay, we can type this in our calculator and we'll have the value for theta 1. Okay, this value is going to be 3.785093762. That will be the answer for theta 1. Theta 2, what we can do there is we see that we can look at the positive x-axis, think of that as 2 pi, and then we need to subtract off the reference angle to figure out theta 2. So theta 2, we would say, is 2 pi minus 0.64350110088. Okay, type that in your calculator. You will end up with a value of 5.639684198. And then there are our two answers for theta 1 and theta 2. Let's look at one other example. Another example might be where your calculator gives you an angle that might not be able to use as a reference, but it actually might be used as one of your answers. Let's look at this example. This is just kind of a slight variation of the two other examples I've showed you. Let's say that we want to solve cosine of theta equals negative 0.9 on the interval from 0 to 2 pi. Okay. We make sure that our calculator is in radian mode. Okay. Once again, on this particular equation, we see that it's already solved for the trig function. Before we do anything, we need to draw a picture and we need to figure out which quadrants those triangles need to be in. So in this case, we have cosine of theta equals negative 0.9. We can put that over 1. We know the ratio is x over r. X is negative in quadrants 2 and quadrants 3. So we know those are the quadrants that our triangles need to lie in. So we know we have a triangle in quadrant 2, and we know we have a triangle in quadrant 3. From here, go to the calculator, and on the calculator, we want to use the inverse function for the function that they've given us. So we want to use inverse cosine. We take the inverse cosine of the value they've given us, which has been negative 0.9. Okay, type this in your calculator. In this case, you're going to get 2.6905658842. And then this is where we probably need to think about which quadrant that particular value that we've just gotten off our calculator is in. Well, up here we know this is pi over 2. Pi over 2 was approximately 1.57. Down here we know that this is pi. That's approximately 3.14. And we see that 2.69 and so forth lies in that second quadrant. So this is actually in quadrant 2. This is one situation where the calculator actually gave us the correct answer, but the problem is it hasn't given us all the correct answers. Okay, so here's what we're going to say. We're going to say that theta 1 is the answer that the calculator just gave us. And so we're halfway done with what we need. And then the problem is, how do we figure out what theta 2 is? Theta 2 would be the angle around to the other terminal side. Well, what we can do is we can see that 2.69 and so forth is in quadrant 2. If we subtract pi minus that value, we know we get a reference angle. Okay, so in other words, I can think about looking for the angle that's inside of here as my reference angle. So a reference angle could be pi, which is 180 degrees, minus the number that I just got. Okay. In this case, this will give me 0.451026818. Now, this is not my other answer. However, it is the reference angle that will allow me to find my other answer. If the reference angle from the x-axis up to theta 1 is this value, then also the reference angle down to theta 2 from the x-axis, negative x-axis would be that value. So theta 2, I would take pi, and I would add the reference angle that I just got. Okay, and that would result in 3.592619465, and that would be my value for theta 2. On any of the kind of problems that you have to solve using your calculator, I can't tell you that there's one way to do it, because first of all, the calculator in some cases may give you a negative radian value that's an acute angle. Okay, I'm not ever really looking for a negative value when I'm solving a trig equation, so I know that that actually wouldn't be the right answer for that. Sometimes, like in this case, it gave me when I typed in my inverse function to begin with, it gave me an answer in quadrant 2. In this case, that answer actually was a solution, but I can't ever really tell you, here's a consistent way to solve these problems. It totally depends on which quadrants you're looking for your answers in, and then basically going and using the answer from your calculator as either one of the answers or kind of as a value that will help you find a reference angle. And your reference angles, do remember, they're always measured from the terminal side to an x-axis. Reference angles will never be measured to a y-axis. Okay, this concludes this example of solving trig equations using a calculator.